So let's go ahead and say that Mr. Brown is trying to estimate the proportion of seniors who are starting to show signs of senioritis.
100%.
He takes a random sample of 35 seniors and finds that 19 of them are starting to fall behind in their work.
More than that.
Describe the sampling distribution of p hats from this sample. Okay. Guys, this is not x bars and mu. This is p hats and p again. What I'd like to do is go through what we did with the p hats so that you can make connections with what we're going to do with the x bars. Okay? That's the whole point of this. All right. Now, tell me something we should do.
Something. 0.19. No. 35 times 0.19.
So you guys want to calculate p hat, which is 19 divided by 35. The giggling and the happiness just makes me think that you guys are happy. I hate it when people are happy around me.
It's like the one time I've laughed all week, Miss Meister.
I hate it when you guys are happy. Hey, what are we getting? 0.54? Okay. 0.54. Oh boy. Now what?
35 by that, and then 35 by like 46.
0.46, but yeah. I knew what you meant. And yet I still felt the need to correct you. Sorry. That's not a very pleasant personality trait.
It is a normal.
At least it's not with grammar. That sounds worse. Like when people correct your grammar all the time.
My grandpa, if I say like in a sentence, he always was like knit and just like.
Okay. So here's the first thing I want to point out, okay? The rule for normality is NP and 1 minus P both have to be greater than or equal to 10 when we were dealing with P hats. That is very obviously going to change when we're going to deal with the X bars because what was the rules for the X bars to be normal? Either my sample size was greater than or equal to 30 or
Crickets.
Crickets? Or we know that the population is relatively symmetric or normally distributed. So if I know the population from which I am sampling is normally distributed, it is okay if the sample size is less than 30. Okay? That's what it would take though, is I'd have to know that.
It
All right.
has to be greater than or equal to 30 or symmetric.
Or the population is a well-behaved population.
Gotcha.
Would not be the population of FST students. All right, now, the other thing I want to point out. Did we do NP and N1 minus P?
No.
No, we did NP hat and N1 minus P hat. Is everybody with me?
Yep.
Why?
Because we're basing it off P hat.
Because we had to. We had to use P hat. Did we want to? No. But it turns out that P hat is a pretty darn good estimator of P. So we're okay with it. Everybody good? All right. Now, what's the mean of all those P hats going to be? I don't know.
Something.
That's our goal. It's P, but we don't know what it is. And when we make our estimate, we're going to say P is somewhere between here and here, right? But we need that margin of error to be comfortable there. All right, now, what is the standard deviation of my P hats? Nice. And that has an answer. 0.084. All right. Now, talk to me about the margin of error. You guys remember how to do margin of error, right?
No.
Yeah.
We do a z star times the standard deviation of the p hats. Okay?
What is the star?
Yeah, I don't remember. It's like
We called it a critical value. Okay?
Yeah.
And we calculated it like this. We drew a normal curve, and if I want to be 90% confident,
Oh.
we did 0 and 1 because it's z's, and we did something like this is 0.90. And if, by the way, if I have 90% in the middle, what do I have on each side? 0.05. And then from there, how do we get z star?
You just do get out the special calculator and calculate the.
So get out your special calculators and calculate it.
Or is it inverse norm?
Is inverse norm. Where is it? Second verse. Oh, yeah. And what are you going to put in for the area? Well, that kind of depends on your calculator. I would get into the habit of just doing the left-hand one, so the 0.05.
To the left.
And you got negative 1.645. Technically, it's plus or minus. Okay, so my z star is plus or minus 1.645. My standard error, we said, was 0.084.
Wait.
And that's how I calculate my margin of error.
Right. And I shall. .13818.
So our margin of error is plus or minus 0.13. And if I needed to compute the interval, I would take p hat for that. Oh my God. I would need to take p hat plus or minus that value, and we could actually come up with the interval, which this looks to be like 0.41 to 0.67. How are we feeling? Is this okay? All right. So, structurally, we're going to do a lot of really similar things. Some of the stuff we're going to do differently with means are going to make total sense. For instance, the rule about normality is going to make total sense. The standard deviation is going to kind of make sense. Then there's one other thing that I'm happy to explain it to you as many times as you want, or you could just accept what I'm saying.
I'll accept what you're saying.
Cool. All right. Now, can somebody tell me the difference between mu and x bar?
Absolutely nothing.
Totally something.
Yeah, but what?
Oh, X bar is
The mean.
from a
X bar is a mean, but so is mu.
it's from a sample and then
X bar is a sample mean. X bar is a sample mean, mu is a population mean, okay? So our goal, how often do you know the mean of your entire population?
Rarely ever.
Rarely ever. The goal of what we're doing today is to come up with an estimate for a population mean based off of a sample mean. Okay, so the problems we were doing yesterday, I gave you the population mean and the population standard deviation. Sigma is the population mean, population standard deviation. S is the sample standard deviation. I'm just all over the place with my language here today. Sigma and S are both standard deviations. One is of the population, sigma. One is of the sample, which is S. All right. We have all kinds of estimators. And in fact, we've used p hat to estimate p. Okay? Now, these are all things, wait, I have those backwards. What is wrong with me today, y'all? P described the population, p hat described the sample. Okay. So here's my question. Which one of these are good at their job in terms of estimating? Does p hat do a good job of estimating p?
No.
I feel like you said earlier.
It does. P hat's a pretty good estimator of p. And it turns out X bar is a really good estimator of mu. The sample means tend to fall right in with the population mean. You guys remember once we took a large enough sample and we looked at that arrow jumping around yesterday? Was it jumping a lot? No, for means it stays right then and there. Okay? Now, it turns out that S is that's not like a super frowny face. It's like a meh. It's not a great estimator of sigma. We still have to use it because it's all we have. So one of the things we're going to talk about later on is as we go to do Z star, and we're not going to use Z star because Z is for good estimators. We're going to learn about a new one that's not as great as Z, but it's what we have to use called T.
You should
Okay?
have made the mouth just a straight line.
Well, it's a little bit sad, just not a lot of it sad, you know?
It's sad.
It's pretty sad.
It's experiencing ennui.
Onset depression.
It's just kind of sad. A little sad, not a lot of sad.
Big sad.
Like you guys thinking about high school graduation and how sad you're going to be to leave this place. Yeah.
Not.
Okay. So the first thing we got to learn how to do here is to go through an example and say, hey, what's the pertinent information? So I'll let you guys read this and tell me what I need to know.
No idea.
There's lots of information there. Tell me something.
Let's do
The average score was 92.
Okay, so when we
Great
say
minds
the
think alike.
average was 92, is that the average of a sample?
Yeah.
Or is that the average of a population?
Oh, the populations.
It's a survey of these 35 golfers, yeah?
Yes.
So it is a sample of 35 golfers. So I'm going to call this X bar.
Man, it could just be a country of 35 people. With
Nah.
hence population.
No.
Oh.
Okay. What else do I need to know? Should I take away from this?
The standard deviation is 4.5.
The standard deviation of what?
The sample.
So that's an S equals 4.5. And that's like, it's important that we make these distinctions, okay? There's one other fairly important piece of information that we haven't really talked about yet.
95% confidence.
That's not the piece I need to know right now, though.
The P hat equals 30.
There's no P hat.
Or P equals 35.
What equals 35?
The survey of golfers that showed their.
P?
So what is that 35?
A sample.
P hat.
P hat is a percentage, you
It's
guys.
like the average.
No,
Not of the
It's a
sample,
sample.
but like.
it is my sample size. N is equal to 35. You guys with me on that? N is my sample size? All right. So let's go through. Let's go through our different things. Let's talk about the shape. Do we have enough to say that the X bars will be normally distributed?
Oh, no.
What were the rules for X bars to be normal?
And it has to be 30 or.
Greater than or equal to, or greater than.
The
or equal to 30.
easiest one is N greater than or equal to 30. Is 35 greater than or equal to 30?
Yeah.
Yes.
So we can say those X bars are going to be normal. The average of all the different possible samples we could get, those X bars will be normal. Okay? Do we know the mean of the X bars?
No.
Nope.
No.
We know the mean of our sample, but what do we know about that 92 since it came from a sample? What do we know about samples?
They're not perfect.
So is that 92
Where's the
correct?
button?
No.
Mrs. Roth accidentally ruined the recording and I haven't fixed it. She accidentally tried to record over it. Okay. Talk to me about the standard deviation of the x-bars.
It's like something over the square root.
Let me just think. I need to do this.
Hi.
For two.
No.
FST.
Yup.
I forgot that was a class. Definitely. Yeah.
Oh.
I didn't mean that as a word. I literally just forgot.
Actually, geometry.
Can I help you with something?
It's actually.
Did you just come in here to say that and leave?
I don't know what she's doing right now, man. Like, she knows that the student teacher we share teaches Algebra 2, and that student teacher is currently teaching her class. So it doesn't make sense that it'd be Algebra 2. I don't know what she wants. I think maybe she thought I
wants to
didn't have a
smoke.
class.
She
Or
wants-
maybe she thought it was AP.
She wants the smoke.
All right. Hey, guys. How do we find the standard deviation of the x-bars?
4.5.
It is not 4.5. That 4.5 is the standard deviation of our sample. Okay?
No. I wasn't giving that as an answer.
Oh.
4.5
Could you give a little bit more?
Divided by
4.5 over the square root of
35.
35.
The square root of 35. Okay.
I was like.
Shut down.
Well, you said it so like
No, I was not.
you were.
5, period.
Over.
Then it was like it. You said 4.
Needed theatrics.
It seemed like a final answer,
Really good. That's all that matters.
and I bet the answer is somewhere near 3/4.
Yeah, 0.76.
0.76.
perhaps.
Okay. Everybody's still okay. All right. Now, remember that time I told you that S was a crappy estimator of sigma.
Oh yeah.
But we don't have we don't know sigma. We'll never know the population standard deviation because think of it this way. If you're estimating the population mean, you don't know the population mean, okay? And since you need the mean to calculate standard deviation, you can't know the population standard deviation if you don't know the population mean. Do you guys see what I'm saying there? Okay? So we have to use the sample's standard deviation even though it's a real crummy estimator. We don't have a choice. But what we do is we say, hey, I need a little bit more wiggle room. So we use a different statistic than Z. We use something called T that is crazy close to Z. It's not the same thing, but it's practically the same thing. Okay? It's like you guys know that like a store brand Lucky Charms is not the same as the actual Lucky Charms, but it's like pretty darn close. T is the store brand Z.
I like how you use the one brand of cereal that you like refuse to eat because of the.
Because it's nothing but sugar.
Well, I was gonna say
All
the
cereal
prawns,
is
but
nothing but sugar.
That's fair. That's fair. Some of them have fiber. But yeah, the leprechauns on Lucky Charms. Except for I actually love Lucky Charms. It's like one of my guilty pleasures. So how do we figure out T? Because T is different than Z. Well, the answer is really, really similar. So I'm going to draw a picture. We said 95% confident, right? Okay. So the picture for 95% confident used to look like this. And it still does. There's really only one difference.
My slope looks terrible.
Well, it's hard to look as good as mine, Jack. That is one of my better normal curves, I think. It's a pretty good looking
That
one.
is a pretty good one.
Okay. Have you noticed I left something out? I did leave the standard deviation out. You think I did that on purpose?
Yeah.
Probably not.
Of course I did.
Sure.
All right. So you don't need to worry about what the standard deviation is here. You're going to label something else.
T.
It's called the degrees of freedom.
All right.
Yeah, this is called
the
Okay,
pedometer.
you guys know me. Am I creative enough to come up with any of this stuff?
I don't
What?
know, cause
We shorthand DF, okay?
This is like the secondary name for the Declaration of Independence.
Jeez. And the degrees of freedom in this case is 34. Does anybody want to guess how we calculate the degrees of freedom? It's literally your sample size minus 1.
Okay.
because it's always n minus 1.
And it's always n minus 1.
Oh,
It's always n minus 1.
When in doubt, n minus 1.
For sure. For sure. Okay. Now, also, this area would be 0.025. 0.025, right, Jack?
yes.
Okay, cool. Cool. See that personality trait of mine of correcting people? It's just super good. It actually means I'm in the best profession possible.
Yeah.
All right.
Educated.
So
erratic.
if this were a normal curve, what would we do to find z star?
You would-
Inverse norm. But inverse norm makes you put in a standard deviation. I don't have one. So let's just pretend we can go to inverse norm. So pretend to go to inverse norm real quick. So if you're pretending, you might hit second vars, but not select anything. Go ahead and hit second vars on your calculators, please.
There's gotta be a new one.
Do you see the one that says inverse t?
Inverse T.
So instead of inverse norm, you're going to use inverse t. Does that seem like a big stretch?
Yes,
No.
we're pushing T.
Pushing
Why would
T.
you make us do that?
Okay. And when you pick inverse t, especially if you're used to having one of the fancy calculators, inverse t does not have a center option. So you just have to put in that left-hand area. It's always the left-hand area.
Nice.
So what area do we have on the left?
0.025.
0.025. You're going to get a negative answer, but it's really both the positive and the negative.
That's what I was.
So, 2.03. Perfect. Okay. So now what is my margin of error? It's going to be the plus or minus 2.03 times my standard error of 0.76. Yeah.
What's the thing by the T? Is that like
You can't tell that's a star?
Is that Z's? Is that just like
It's just like Z star.
Just for
Z star is for proportions, T star is for means. And here's the difference between the star and just the T, okay? The T, sometimes we would just say Z equals this, and sometimes we said Z star equals. Z star or T star are theoretical values.
so not like certain.
They're not the actual value from your observed sample. So if I say Z equals, like when we were doing those tests, okay, that's because that is the Z score for a very specific observed sample. Okay? Z star is just saying, hey, where's that theoretical boundary for the middle 95%? It's a theoretical rather than an actual. That's what the star signifies.
1.5.
That's the answer?
Yeah.
I bet it's like not exactly 1.5.
Yeah, I said 1.54.
1.54 sounds a little bit better.
I
Okay?
put 2.8.
All right. Now, we haven't done the interval yet. You know what I'm saying?
No.
Do we have an interval?
Do we?
And in fact, do we have enough information to say Mr. Richards, he's not going to take the golf team there if the average score of the course is less than 82, because then it's too easy. He only wants them on harder courses. Okay? Do we have enough information to answer whether or not this course is less than or equal to 82?
Yes.
I mean,
I think
it
so.
says in the first.
It says in the first one that the average score is 92.
That the average score of our sample was, but maybe our sample was a group of bad golfers.
Okay.
Do you get what I'm saying? So what we need to do is come up with that margin of error that accounts for the fact that that came from a sample, and the sample's not perfect. So we're going to take that 92, this one right here,
That's definitely not the average score of our team.
Depends on the course, doesn't it? Plus or minus
More like 92.
our margin of error. That's the whole point, is getting that margin of error to come up with the interval. And now, guys, I'm not very good with numbers, but I'm pretty sure this is 90.46 to 93.54.
You're not good with numbers?
I feel like you're lying to us.
I would never lie. It's not in my nature at all. I've never lied to a group of students.
I'm sure.
You just lied there.
What are you talking about?
Stop the cap.
Prove it.
Never lied. You just lied there.
Stop
Hold
the
on.
cap.
So, what's the answer to the question?
Oh, there's an answer?
No,
Nah.
you should
No.
not take the team in the course.
He's not going to go there if the average score is lower than 82.
Oh,
So you should.
So I'm going to say, yes, he should.
yes, he should.
Because the entire interval is above.
The entire team sucks.
Damn.
Basically.
This is about the average score of the course, Jack, not the team.
Oh.
Still.
Still.
You guys want to talk about hummingbirds next?
Can I use the
Not
restroom?
You don't
really.
have a choice?
Really? You don't really have a choice.
So why give me a choice?
Why are old people so obsessed with hummingbirds?
Because they're cool.
They're cool. I'm going to Arizona.
Maybe you'll see a hummingbird.
We're gonna, like,
If you do, you should take a picture of it.
I don't know, actually. I'll try to. If we're, if we.
Oh, you like hummingbirds? Name every hummingbird.
I don't know any hummingbirds, but I think they're cool.
No.
What if we get stuck?
High school experience was literally a pandemic and a World War III.
I know.
Oh.
Yikes.
A small group of 15 hummingbirds has been understudied in Arizona. The average weight of these hummingbirds is 3.15 grams with a standard deviation of 0.33 grams. It is reasonable to assume that the weights of all hummingbirds are normally distributed. Everybody good?
Yes.
All right. Anything you guys want to look at this and you're like, oh yeah, I definitely want to start writing some stuff down?
We've got a small group of hummingbirds. That's x equals 3.1.
How about X bar? The average of our sample is 3.15. Cool. What else you guys got?
N equals standard deviation.
N equals 15. What else you got?
The S thing was,
S equals 0.33. Look at you guys go. Look at all that impertinent information. All right. Will the distribution of all the sample means, so not the hummingbirds, but the sample means, be approximately normal?
Less than 30.
N is equal to 15, which is, in fact, not greater than or equal to 30. Cool? So can we use that to say that they're normal? That the X bars will be normal?
No.
No. However, what can we say about this population? What were we told?
Small.
Since the population that we're drawing from is normal, those X bars will still be normal. Guys, think about, remember those Olympic marathon times? We didn't need a huge sample for those to be normal because the population was better behaved. Okay? So how do we know? Population is normal, though.
So even when it's not normal, it's normal.
If I don't know anything about my population, I need that big sample. If I know enough that my population is a good, symmetric, well-behaved population, then I'm willing to take a smaller sample size and still have that normal condition. Okay. Use your sample to estimate the standard deviation of the p-hats. Help me out.
15 divided by.
No, 3.15 divided by, no, 0.33 divided,
The standard deviation of my sample as an
Divided.
estimator for sigma
divided by the square root of 15.
divided by the square root of 15.
So, why is that not the standard deviation of x?
Oh, thank you, because that's bad. That's like real bad. That's not p hats, guys. That's definitely x bar. Thank you, Mar.
Oh,
I got 0.085.
0.085. Okay. All right. Then we got to find that t star. What will the tails be if this is 0.99?
0.001.
0.005. And you're gonna do, and what's my degrees of freedom?
14.
14, perfect. Okay, and what are you guys getting for T star?
I have 2.97.
2.97. Is it 97 or
Huh?
97 or 98? This morning they said it rounded up.
It would round up.
Okay. And then, so what does that make my margin of error? It's going to be 2.98 times 0.085.
The 2.98 is plus or minus, right?
Yeah, I mean the whole margin, like, if you don't write the plus or minus, everything's fine. Because like, what do you do with your margin of error? You plus or minus it. It'll come out in a wash in the end.
Okay.
What are we getting for that?
0.25.
Okay. So now, the hardest part for you guys is going to be the interval, which goes from, you're going to use the x bar plus or minus that margin of error. Okay, and this is the part that everybody forgets. It is the x bar from your sample, because that's what your estimate says. Your sample mean is your estimate for the weight of the hummingbirds. So, do you guys get 2.9 and 3.4? All right, so what does that really mean? The true mean weight of the hummingbirds, of all hummingbirds, okay, is between 2.9 and 3.4. Okay, lastly? No?
No.
No? Why not, Jack?
Well, because we just said it's between 2.9 and 2.4.
What if that had been 3.5?
No.
Yeah.
Yes.
If this said more than, what if this said less than 3.43? What would the answer be? Yeah. What if it had said
Would it have to be less than?
3.1? What would the answer be?
Yes.
I mean, it's somewhere.
Can we assume that it's 3.1?
Yeah.
No. Can we say it's not 3.1?
Yeah.
No.
No.
Because 3.1's in the interval, but there's lots of things in the interval. So we can't say for sure it's 3.1, but we can say it's somewhere, it's possible that 3.1's a possible mean weight, but not always. Cool. See, this wasn't so bad, right? Do we see the connections at least?
Yeah.